Imagine for a moment you're gazing at the night sky and suddenly realize the stars aren't where they should be, that there's a pattern in the universe that simply shouldn't exist, that there are regions in the cosmos so empty they defy our understanding of reality. What if I told you all of this is real? That our universe hides anomalies so strange and unsettling they make scientists question if we truly grasp how the cosmos works. Hey there, cosmic explorers. Welcome back to Cosmic Frontiers. Today, we're diving into one of the most perplexing aspects of the universe, cosmic anomalies that simply shouldn't exist. We'll uncover the mysterious axis of evil that cuts through our universe, explore cosmic voids so gigantic they'd make our Milky Way look like a grain of sand, and get acquainted with colossal structures that challenge everything we know about how the universe formed. Get ready, because by the end of this video, you'll be questioning if we truly know the universe we live in. And before we kick off our journey through the most disturbing cosmic mysteries ever discovered, I want to remind you that we're on an incredible mission towards 1,000 cosmic explorers. Every discovery we make together brings us closer to that goal. Our first stop on this journey through cosmic mysteries takes us to one of the most unsettling discoveries in modern astronomy, the so-called axis of evil. No, it's not a concept pulled from a sci-fi flick, but a real anomaly discovered when scientists analyzed the cosmic microwave background radiation, our best photograph of the universe, when it was just 380,000 years old. To grasp just how surprising this discovery is, imagine you take a photo of a massive crowd in a football stadium. You'd expect people to be randomly distributed, right? But what if, upon looking at the photo, you found that everyone wearing red was perfectly aligned in a straight line, cutting across the entire stadium? It would be so improbable you'd immediately know something very weird was going on. That's exactly what's happening with the axis of evil. When the WMAP and Planck satellites mapped the cosmic microwave background, they found that the most significant temperature fluctuations aren't randomly distributed across the sky, as they should be in a truly homogeneous universe. Instead, they align along a specific axis that spans the entire observable universe. The discovery was so unexpected that scientists initially thought it was an instrumental error. Kate Lan and João Magejo, the researchers who first identified this anomaly in 2005, spent months checking and rechecking their data. But the reality persisted. There is a preferred direction in the universe, something that contradicts one of the fundamental principles of modern cosmology. Cosmologist Max Tegmark dubbed this discovery the axis of evil precisely because it threatens our basic understanding of the universe. According to the cosmological principle, the universe should be homogeneous and isotropic on large scales, meaning it should look the same in all directions. But the axis of evil suggests there's a special direction in the cosmos, as if the universe has an invisible backbone. The implications are profound and unsettling. If the universe truly has a preferred direction, it means our position in the cosmos might not be as common as we thought. It could suggest we live in a special region of the universe, or that there are fundamental forces and processes we don't yet fully comprehend. But cosmic anomalies don't stop there. Get ready to encounter something even more baffling. The great cosmic voids. Imagine a gigantic city where, all of a sudden, you find a completely empty block, not just without buildings, but literally nothing. No land, no air, just absolute emptiness. Now multiply that block by billions and billions of times, and you'll have an idea of what cosmic supervoids are. The largest of these known voids is the Eridanus supervoid, discovered in 2007 by a team led by Lawrence Rudnick. This cosmic void is approximately 1 billion light-years in diameter. To put that into perspective, our galaxy, the Milky Way, is only 100,000 light-years across. That means you could place 10,000 Milky Ways side by side and still not completely cross this void. But here's what makes this truly disturbing. These voids shouldn't exist, at least not on such a gigantic scale. According to our models of universe formation, matter should have been distributed more uniformly after the Big Bang. Yes, we expected denser regions where galaxies would form and less dense regions between them, but nothing on the scale of these It's as if someone used a giant cosmic spoon to scoop out chunks of the universe. And the weirdest part is that these voids aren't just less dense, they are almost completely empty. While normal space between galaxies contains about 1 atom per cubic meter, supervoids contain about 1 atom every 10 cubic meters. The discovery of these voids led scientists to rethink their models of cosmic structure formation. How can something so empty form in a universe that started relatively uniform? One of the most intriguing theories suggests these voids are scars left by exotic events in the early universe, perhaps related to cosmic inflation or yet undiscovered physics phenomena. Now, brace yourselves to meet the most baffling anomaly of all. Cosmic structures so gigantic, they simply shouldn't be able to exist. I'm talking about objects like the Sloan Great Wall, the huge LQG, and the most recent discovery, the Hercules Corona Borealis Great Wall. To understand how absurd these structures are, we need to talk about something called the cosmological horizon. Imagine you're trying to organize a surprise party for someone, but you can only communicate by letters that take weeks to arrive. How long would it take to coordinate all the details with people spread across the entire country? Now imagine trying to do that with people spread across the entire planet, with letters that take months to arrive. In the early universe, there was a similar limit to how large a structure could grow. This limit is determined by the speed of light and the age of the universe at the time of formation. Structures larger than this limit simply wouldn't have had enough time to form through normal gravitational processes. But then, in 2013, Roger Clouse and his team made a discovery that shook cosmology. They found the huge LQG, a group of quasars so vast it stretches for 4 billion light-years. To put that into context, this structure is so massive that light would take longer to cross it than it took for Earth to form. And in 2014, the discovery became even more unsettling with the identification of the Hercules Corona Borealis Great Wall, a structure spanning an incredible 10 billion light. This is the largest known structure in the universe. So vast it challenges our fundamental understanding of how the cosmos works. The problem is that, according to our most accepted cosmological models, structures larger than 1.2 billion light-years simply shouldn't be able to form. It's like finding a 200-story skyscraper in a city where the laws of physics only allow for 10-story buildings. Something is fundamentally wrong with our understanding, or these structures form through processes we don't yet know. Astronomer Istvan Horvath, who participated in the discovery of several of these megastructures, described the scientific community's feeling as an existential crisis in cosmology. These discoveries forced scientists to question whether the cosmological principle, the idea that the universe is homogeneous on large scales, is truly valid. Some of the theories proposed to explain these anomalies are truly exotic. One suggests we live in a universe that is part of a larger multiverse, and that these gigantic structures are fingerprints left by neighboring universes. Another, even more radical proposal suggests that our understanding of gravity is incomplete, and that there are fundamental forces operating on cosmic scales that we haven't yet discovered. But perhaps the most fascinating aspect of these anomalies is what they tell us about our journey of cosmic discovery. Just a few decades ago, we thought we had a reasonably good grasp of the universe. We knew the galaxies, understood cosmic expansion, and had models that seemed to explain how everything formed. Then we discovered dark energy, which makes up 68% of the universe and accelerates its expansion in a way we can't explain. We discovered dark matter, which forms 27% of the cosmos and interacts only gravitationally with normal matter. And now, these cosmic anomalies show us that even the remaining 5% of the universe, the normal matter we're made of, behaves in ways we can't fully comprehend. It's humbling and exciting at the same time. Humbling because it reminds us how little we truly know about the universe we live in. Exciting because each of these discoveries opens new frontiers for exploration, new questions to ask, new mysteries to solve. Think about it for a moment. You are living in a truly special time in human history. You are witnesses to discoveries that are rewriting our fundamental understanding of reality. Each of these cosmic anomalies is a reminder that the universe is stranger, more complex, and more fascinating than we ever imagined. And perhaps that's exactly what makes our journey as cosmic explorers so thrilling. We're not just learning facts about the universe, we're actively participating in humanity's greatest adventure of discovery. Every question we ask, every mystery we encounter, brings us one step closer to understanding our true place in the cosmos. So, cosmic explorers, let's take a moment to absorb everything we've uncovered today. The axis of evil that challenges our understanding of cosmic homogeneity, the supervoids that are too large to exist, the megastructures that violate the fundamental limits of formation. Each of these anomalies reminds us that the universe holds secrets we've barely begun to imagine. But this leads us to a profound reflection. If the universe can surprise us with such fundamental anomalies, what other wonders and mysteries still await our discovery? What other truths about reality are still hidden in the depths of the cosmos, waiting for the next generation of telescopes and the next generation of cosmic explorers to reveal them? Perhaps these anomalies aren't flaws in our universe, but rather clues left by nature to guide us toward a deeper understanding of reality. Perhaps each anomaly is an invitation to expand our mental horizons and question our most fundamental assumptions about how the cosmos works. Now I want to hear from you, my dear cosmic explorers. Which of these anomalies most challenged your understanding of the universe? Was it the mysterious axis of evil suggesting a preferred direction in the cosmos? The gigantic voids that are too large to exist? Or the megastructures that defy the laws of cosmic formation? Leave your thoughts in the comments. I want to know which of these mysteries intrigued you the most. And since we're talking about cosmic mysteries, cosmic explorers, what enigma of the universe do you want me to talk about in the next video? Supermassive black holes that grew too fast, hawking radiation that no one has yet detected, or perhaps gravitational waves that are revealing aspects of the cosmos we never imagined? Leave your suggestions in the comments. We're on an incredible journey towards 1,000 cosmic explorers, and each of you who joins our crew brings us closer to that goal. If this video expanded your cosmic horizons and made you question your understanding of the universe, join our community by clicking subscribe. Like this video if it made you look at the cosmos with new eyes, and share it with someone else who also loves the deepest mysteries of existence. In the next video, we'll explore an even more baffling mystery: the evidence that our universe may not be the only one, and how scientists are searching for signs of parallel universes. Until then, keep looking at the stars and questioning everything you think you know about reality.